Hello everyone, we are Group 7. In the coming 5 minutes, we're going to introduce some facts on how climate change deteriorates global water security, and most importantly, we will make some recommendations to deal with the current problems. According to the United Nations, both quantities and quality of water are taken into considerations when assessing the level of water security. Power generation contributes more than 75% of global greenhouse gases emission, leading to global warming, hence climate change. The evaporation rate increases with the temperature that will lead to higher precipitation, causing storms and flooding that may contaminate the freshwater resources. On the other hand, the rainfall distribution will become more uneven, that some water-scarce countries will experience more severe droughts and water shortage. Water insecurity implies that there is shortage of quality water for drinking and sanitation. Each year, 829,000 of people are estimated to die from diarrhea due to water insecurity. In the following parts, my groupmates are going to make recommendations to relieve the impacts on water insecurity brought by the climate change.
The ever-increasing drought events exacerbated by climate change is affecting water supplies and increasing its demand, leading to water stress. For this problem, the Washington State Department of Health advises individuals to conserve water use to help decrease the impact of this issue. However, it also suggests that people are unaware of their daily water use that gets wasted. On average, 115 liters of water is wasted per day per household. Thus, our first recommendation is building a water conserving rewards app. The app would track the level of water being consumed compared to the average household needs. When consumption of water is kept at a healthy level by the end of the day, the household earns points that can go towards unlocking rewards, such as discounts on groceries or on their next water bill. We believe this can help promote safe water use and decrease the high stress on water, which is a necessary step towards better adaptation to climate change.
For our second recommendation, we wanted to tackle the issue of high water use in agriculture that can't be sustained as we adapt to water-limited conditions. According to the UNESCO report in 2023, the agriculture is responsible for depleting 70% of groundwater sources, affecting water supplies and increase the demand. Not to forget that many of the drought events that stunt the plant growth and lead to soil erosion, affecting the arable land and undermining the food and water security, all accelerated by the climate change. We understand that the current crops being grown like wheat and cereal are important for everyone. Thus, we propose genetically modifying them to sustain and thrive in water-limited conditions. According to the Center of Research in Agricultural Genomics in Spain, this plant engineering technology is available and not difficult to obtain. Their approach revolves around resinosteroid receptor hormones that they found use tissue-specific pathways to mediate certain developmental responses, and by increasing the presence of these hormones in the vasculature of the plant, it yields resistance to drought without consequences to growth. This can be further investigated, of course, in plants with cellular specificity.
For our third recommendation, we looked over the floods caused by severe weather events. We found that these impact water resources and lead to water pollution. According to the Delaware Department of Natural Resources and Environmental Control, the degradation of wetlands have an impact on the severity of the floods. This is because wetlands are natural barriers against floods. They also absorb flood water and aid in providing its quality and supply. To restore these wetlands, the United States Environmental Agency suggests that the first step in the project is to reform the local ecosystem, which was degraded due to the use of harsh chemicals like cleaning products. Thus, to remove these stressors, we recommend creating a mandatory label that would be installed on the back of products that contribute to the destruction of these wetlands. This is to raise awareness and give a perception of control and hope at an individual level.
The decline of glaciers, snowpack, and wetlands as a result of climate change has a negative impact on urban water security. Therefore, there is a need to store water as cities grow and freshwater availability declines. We propose an approach that emphasizes the augmentation of water supplies. This could be done by having cities mandate the installation of rainwater tanks as part of their residential building codes. This would then allow individual households to have water that is decentralized from the main city water supply. These water tanks could also be connected to plumbing for internal supply for toilets, washing machines, and external supply for garden watering, as is the case of the South Australian residential codes. Of course, we recognize that this is not enough. Coming up with community-specific measures that ensure water availability, such as desalination of seawater in coastal areas for industrial use, is also an important area of research for cities and is part of augmentation of urban water supplies, though it is limited to coastal cities, hence the importance of giving each individual household in all urban cities power through reserving their own water by using rainwater tanks.
So, in conclusion, climate change induced water insecurity puts health at risk. We, as a collective, have to find solutions that can be applied across settings in order to adapt to the changing water supply and minimize health impacts. Our solutions push individuals and industries to be more conscious of their consumption habits and to subsequently make feasible adjustments to achieve water conservation.